Hello everyone. Now that we have a basic understanding about how databases store information in tables, we're ready to start investigating how we can bring those tables and that data into our application. In this video, we're going to explore the select statement. We'll cover the basic usage of select, and then also a few major features that allow us to more precisely target the data that we're interested in receiving. Specifically, we're going to look at where clauses, which put conditional filters on each row, and join clauses, which let us get data from more than one table at once. We'll practice with a few basic examples that show us how these queries run, and then see how we can execute them from in JavaScript code and pull out those results in our server-side programs. So with that description out of the way, let us begin. So I'm going to be running all of these examples here in my JavaScript file, which means just like last video, I'm going to start by importing that library. I've already installed it with Bun, but once I've done this, I can create a connection pool exactly the way we did last time, specifying where the database is, as well as what port we connect on, the username, password, and database that we are interested in connecting to. And I'm actually going to use the exact same database that was used in the last video, my database demo that has all of that politician information. And in fact, I've even populated that table with some real congressional data so that we have something to query, because you can't really query unless there is data present. So now that I've established my connection details, I have to create the database connection by calling pool.connect. And remember, this is an asynchronous function, so I either need to await it or put the rest of my code in a .then. But now that we've done that setup, we actually have everything we need to start writing selects right now. So the select statement, it specializes in querying and filtering information. So you might remember in our big chart that we built of create, read, update, delete, and DML and DDL, select was right there in the read column. That's what select is for, is reading information out, but it does more than that. It also allows us to filter and be picky about what data we're getting. So the basic structure of a select, like the most simple one you can write, is select some group of columns from some table. So as an example, let's say I wanted to get every single politician, their first name and last name, out of the politicians table that exists on our database. I could write a request, select the first name, column, comma, the last name from that politician table. And what we're doing here is putting each column we're interested in, separated by a comma, and the table that we expect all this information to be in. If I then look at my results, which remember we can do by taking our connection, sending it that query, this isn't just limited to create, we can put any kind of statement in here. If I await this, I will get back some results. And remember, this comes back as an entire response object. So if I'm interested in just the data that was returned, the way I can access that is by accessing this array that's returned in results rows. So I could say let each row of the result rows here in my JavaScript, let's say console log each one of those rows, which because it's going to be a whole object with all of our columns in it, I'm actually going to JSON stringify it. Say, give me that row and I will print it out, all of the details. Now, I've set up this query. If I go and I run my JavaScript program here, you can see when it runs, I get back all of this information, every single congressperson's first name and last name. So that's already useful. This allows us to store things in our database and retrieve them all pretty quickly in just the fields we're interested in. But it's not very filtered. It can be common as we are building out tables, getting more and more complex data models, that we have dozens, hundreds, thousands, even millions of rows. Even just our politician data here, there's a lot of information in there. I might not always want all of this information every single time. And that's where that filtering part of the select really starts to become useful. When we're using select, more often we only want some portion of the data. To filter, we can write a where clause on our select statement. So the way that we do that is we write the same exact statement that we did before, select columns from some table, but now we add something else on the end. We write where and then whatever conditions that we want. And these conditions are Boolean conditions. They're things that are true or false about each row. They're going to look decently familiar if you're up on your programming, but SQL has some of its own syntax, so things look just slightly different. As an example of a where clause, let's say what I am actually interested in is just the senatorial mics. I only want people who are in the Senate and whose name is Mike. So I could, if I wanted to, select first name and last name and chamber from each one of these politicians and loop through and filter them right in my JavaScript. But it's going to be much more efficient and my program will look much more clean if I can write all of this into the select itself. And the way that I'm going to do that is I'm going to say select star. This is just a shorthand for every single column. Give me all of the columns from politician. And now I'm going to add this where that politician that we're getting back is a member of the Senate. So here you can see I have my column equals some value, and that value, because it's a string, it's in single quotes. Please remember, in SQL, single quotes are for strings, double quotes are for identifiers. It's actually, I could put double quotes around something like the column name or the table name, and that would make it sometimes more case sensitive, more exact, lets you capture things like spaces. But now I'm saying select all of the details only of the rows where they're a member of the Senate. So this will give me 100 results. But there were two parts to my question. I wanted people in the Senate who are named Mike. If I have more than one condition on my where clause, I can join them with Boolean conjunctions, the same ones that we use in a language like JavaScript. I can say where they're a member of the Senate and their first name equals Mike. If you want, you can even do things that are wildcard. Like we know there's Mike and Michael. If I wanted to do anything that starts with MI so I can get either of them, you can do that by using like instead of equals, the percent as our operator. But now I have this query that's saying, get me a lot of information about each person, but only just these couple that I am interested in. And if I write my results as running this query, whatever we get back from this just senatorial Mike's statement, I can print out these results again for each row of the rows that we get back, console log. each one of those rows. And now, when we run our program, you can see we got back a couple more than just Mike's. There is Michael Bennett, Michael Crapo, Mike Lee, Mike Rounds, Mike Braun, and Mitt Romney. But we have all of the details. Because we used star, we got back every single row or every single column for each one of these rows. I could actually put this, if you want to see it, a little bit more visually less noisy. I can look at it right in even something like a browser here. Say, select me from politician with those conditions. And you can see it has filtered. That table shrunk down suddenly, and we only have just those rows that match our conditions. And this is really powerful. Hopefully, you're already starting to think about endpoints and how this can be associated with endpoints. If you recall, a lot of what we were doing was allowing people to query with a get back a bunch of information, but then apply some filters of their choosing. This is a really great fit. Endpoints and SQL statements can link together and make a really clean interface for bringing data from persistent storage all the way through to a web request. So now we've looked at pulling data in and also filtering a table down to just a couple rows. The last feature of select statements that I want to cover in this video is when we have questions that are too complicated to ask all at once. So as an example of this, we had two tables in our demo database from last video. We had politician, which had all of the information about individual people. We also had chamber, which had details about each one of these chambers. There's the House and there's the Senate, and both of them have a current leader. I might say, well, in my program, I want to get the last name of the leader of the Senate. So there's a problem here. The way that we linked these two tables together, the only information that's present in chamber is just the bio guide. And remember, we had described this as a foreign key. We had said what this actually points to is some reference of some bio guide in the politicians table. We had set that up, if you remember, in the constraints. We had even said the leader column must be there. If we looked at the entire column DDL, it is enforcing this constraint, so we know we can find this person. But with the way this is written right now, if we only use select and while, or where, we would have to first grab the Senate row and read the leader. Then in a second query, we would have to grab the politician with this bio guide, where bio guide equals S000148. Fortunately, there's a way in SQL that we can combine these two into one single statement. When we have a question that requires more than one table, we can join those two tables together. So typically, joining has to specify the candidate key and how that maps to the foreign key. So in our case, this is that bio guide. We have to say that leader in one table is bio guide in the other. But the way that we would actually write this statement is we select whatever columns we want from our table 1, and then we say join to table 2 on table 1 key equals table 2 key. And believe it or not, this on is just another sneaky where. You can actually throw whatever conditions you need in here. If there's an and, like if you have multiple columns together that join two tables together, you can and here if you need to. You can do numeric comparisons if you need to. But this will give us one really big table that has all of the columns from both of the tables. And there is something important to note about join. Every single possible combination that satisfies this on will be visible, will be present in the resulting table. So if you join and you don't pick a unique value, you'll get row 1 matched to row 1 on the other side, row 1 matched to row 2 on the other side, row 2 on the first side to row 1, row 2 to row 2. You'll get this Cartesian join of every possibility as its own row in your results. So do be careful that you're actually picking a foreign key here. But if you do that successfully, then you can add in whatever conditions you want afterward, exactly the way we do with a regular select statement. So now that we've discussed that, let's go back to our example that we wanted to find the answer for, the Senate leader. With this new syntax, now we can say select whichever columns it is that we care about, which maybe for us we'll say the first name, last name, the member of, and the party. That's enough for us to verify that we found the right person, the Senate person, he's in the right chamber, his first name, last name. We pick one of the two, and we could pick either one here. I'm going to start with the chamber. And remember, not all these details are here. In fact, most of them aren't in this table. So then we'll join to the table where they are, the politician table. And one other quick little syntax I'm sneaking in. Anytime you put a table name, you can put an abbreviation for it right after. And the reason that that helps is when you write a condition where we have that table 1 key equals table 2 key, I can actually say C instead of chamber. It just saves you some typing if you make an alias, it's called. So I'll say the C leader is the same as P bio guide. And we had said that this is a foreign key. This is a primary key. So this should be a unique combination that we get. And then we were only interested in just the leader of the Senate. So we add this where clause so that from all of our leader rows, only the Senate one is left. This is a pretty dense query. We've actually got a lot of information here. If we were doing this in just JavaScript code, you'd be looping over each chamber and looping over each politician. You'd have a bunch of nested loops, a bunch of if statements. But here, we've expressed that entire concept in one single statement. And that's really the main benefit of using selects over just pulling all the data in, is that the rest of our program, all we need to do is fetch out those results, which are Senate leader query, just goes into query like all the others. And then because this one should only have one single result, I don't even need a loop. I can say the Sen leader is just get me that very first row. And then I could either pull out his individual properties like first name, last name, member of, or maybe I will just console log him the way that we have all of our others, JSON stringify the entire object. I'm even going to pretty print it by adding those extra 2 arguments to stringify. Maybe I'll even add a couple extra new lines just so we can see where he is. But now, if I go and I run my program one last time, we can see we get back just the information we cared about. We have just a couple columns from one single data point from all of the information in both of those tables. And that's what's so great about select, is it lets us very cleanly and precisely identify just the things we want and isolate all of that complexity into the SQL statement itself. So in this video, we've looked at just the beginning of what you can do with select. there are features we didn't even talk about, like subqueries and other filtering mechanisms, other things we can do to aggregate columns in the select clause. I heartily encourage you to go out and read more, explore everything that you can do with select. What we've done in this video, just where clauses to filter and join clauses to bring tables together, is still more than enough to write a ton of really interesting code that asks complex questions of your data. In our next video, we're going to look at how we can embed these types of queries in our web programs, how we can design endpoints around asking information of our tables. So I look forward to that, and I will catch you all in that next one.